Dear students, welcome to one shot series of queuing lecture. So first 4 lectures were, you can say, basics ones. Whatever I taught in graphical, simplex, transportation and assignment, varieties are not possible. Now these next 4 lectures of industrial engineering, from the lecture you have to develop fundamentals, and when the fundamentals are clear, you will be able to hit every single problem. So today's lecture is the queuing theory. Of course, it's a one-shot series. So what we are doing in the one-shot series, once again, that whatever we feel important, we are discussing. We are doing some problems. With the help of this, you should be in a position to develop fundamentals. Now these 4 lectures are fundamental based. You have to develop fundamentals, and I'm sure that if you grasp whatever I'm teaching in one shot series queuing, if you understand it, you will hit every single problem of GATE, civil services, whatever examination you are giving, either objective or conventional, you will be able to hit. So be attentive. This is our dream drona. As I tell in every lecture, it is not effort of one teacher, it's a group of teachers. The topics that I'm going to cover here in queuing, I'm going to discuss some basics of queuing, some proof, then single service server finite length problems, single server finite length problem, infinite and finite, both I'm going to discuss. And then I'm going to touch little bit about multiple server problems. These are my credentials. I'm Dr. 𝐂𝐨𝐻 Singh. I'm gold medalist from Aligarh Muslim University, because I topped university during my graduation, 93-97 batch. I'm MTech and PhD from IIT Delhi. And between MTech and PhD, I worked for engineering services for 1.5 years. I'm also a researcher. Presently, I'm working in worm forming. So I am, as per Scopus data published, I'm top 5% researcher in the world. So now, queuing. Queuing. Queue. Please be attentive. Okay, while going through course of queuing, you please be attentive. Let us understand some basics. Let us understand some basics. Let us say there is a service facility. Let us say there is a service facility. By God's grace, if we meet in some live classes, or we are also planning some interactions, then we will have much deeper discussion on queuing. In one shot, purposefully I will not go to that extreme, because I am not available to clear your doubts. But whatever is required to crack any exam, everything will be there in this one shot lecture. Suppose there is a service facility, for example, bank teller. So people are coming. As the first person comes, server is chit-chatting with that customer. As the first person comes, server is chit-chatting and that how much you want to withdraw from the bank, how much is the account. Some kind of discussion is happening between the teller and the customer. Now, by the time when the more customer comes, they will form a queue. By the time more customer comes, they will form a queue. Okay. And this queue can be extended to infinity. Queue can be extended to infinity. And this is bank premises. This is the bank premises. Everything is happening within the bank, and the queue can be extended to infinity. There is no restriction on the queue. There is no restriction on the queue. Correct? Now, this is called queue. And if you include the person being served, it is called system. Excluding the person being served is called a queue. And if you consider the person also being served, that whole thing is called a system. System and queue. So average number of waiting in the queue is called queue length. Average number of people waiting in the queue is called queue length. And average number of customers waiting in the system is called system length. Average number of customers in the waiting in the system is called system length. So including the person being served, customer being served, it is called a system. It is called a system. So everybody understood what is system and what is queue? Now you will get an intuition that if this is the case, ls minus lq should be equal to 1. If this is the case, ls minus lq should be equal to 1. It will not equal to 1. You know why? Because there will be some time period. Because there will be some time period during which the system is idle. During which the system is idle. There will be time period during which the system is idle. So in the average, that is also being calculated, na? While calculating this average, system idleness is also taken into consideration. System idleness is also taken into consideration. Now, in your syllabus of your competitive examination, there is Poisson arrival, and exponential service. Poisson arrival and exponential service. The probability distribution with which the arrivals are approaching the first facility follow a Poisson distribution. Of course, if you get into the probability, what is the Poisson distribution? It's a refined way of binomial distribution. It's a refined version of binomial distribution. And the rate at which the service is being rendered by the system has got exponential distribution. Exponential probability distribution. If you change the probability distribution, there will be change in the solution. But for competitive examination, pretty much we are restricted to Poisson arrival and exponential service. Poisson arrival and exponential service. Okay. Now, if you superimpose these two probability distribution, that Pn is the number of customers in the system. Pn is the probability probability that there are n number of customers in the system. Pn is the probability that there are n number of customers in the system. Okay. And let us say lambda is the arrival rate per unit time. Lambda is the arrival rate per unit time, but arrivals follow a Poisson distribution. Arrivals follow a Poisson distribution. And let us say the mean rate is lambda number per unit time. And mu is the service rate. Mu is the service rate per hour. Mu is the service rate per hour. Now there is a parameter called rho. It is nothing but lambda by mu. This mu is called percentage utilization or traffic intensity. Traffic intensity or percentage utilization of the facility. Percentage utilization of facility, lambda, rho is called lambda by mu. Rho is also called traffic intensity. So this Pn is rho raised to power n into P naught. Okay, na? And length of system is nothing but summation 0 to infinity n Pn. Once again, Pn is the number of customers in the system. And length of Q will be nothing but summation n from C to infinity n minus C Pn. So this is the probability that there are n customers in the system. Ls is the average system length and Lq is the average Q length. Kindly remember that whatever is the situation, these formulas will not change. How these formulas are coming up? By superimposing the Poisson distribution and the exponential distribution. Poisson arrival and exponential service. So these formulas will come up by superimposing these two distributions. Pn is equals to rho raised to power n P naught. Ls, length of system. What is the length of system? Average number of people that are there in the facility. Average number of people that are there in the facility, length of system. And Lq is average length of Q. Average length of Q that will form time to time before any service facility. Once again, what is Q? Excluding the person being customer being served, whatever is the length is called a Q length. So now these formulas will not change whatever is the Q discipline. So now let us get into these formulas one by one. Let us say single server, infinite length. Single server, infinite length problem. What is the infinite length problem? That the Q can be extended to infinity, there is no restriction. Q can be extended to infinity, there is no restriction. That is called infinite length problem. Once again I will remind you, please see the screen very carefully. So now For probability, can I say summation Pn from 0 to infinity should be equal to 1? Summation of probability of all the permutation and combination should be equal to 1. Considering all permutation and combination, the summation should be equal to 1. So here I can say that P0 plus P1 plus P2 should be equal to 1. And what is Pn? It rho raised to power n P naught. Rho is nothing but lambda by mu. Put it here. So can I say P naught plus rho P naught plus rho square P naught, and it goes up to infinity, should be equal to 1. Take P naught common out. So 1 plus rho square infinity should be equal to 1. Correct? If rho is less than 1, then it's a geometric series. Can I say A divided by 1 minus R? So P naught is equals to 1 minus rho. Probability that there is nobody in the system is 1 minus rho. Probability that there is nobody in the system is 1 minus rho. Probability that there is somebody in the system. Probability that there is someone in the system. Someone in the system is nothing but minus P naught. P naught is the probability that there is nobody in the system. So 1 minus P naught is the probability that there is someone in the system, and it should be equal to rho. So that is the reason rho is called percentage utilization of server. That's the reason rho is called percentage utilization of server. Correct, na? See, everything will come from these formulas. Everything will come from these formulas, okay? Now, length of system. Length of system is Ls. And what is the Ls? Summation n is equals to 0 to infinity npn. Correct? So let us do that. Ls is nothing but 0 means 0, P1 plus 2P2 plus 3P3. Let us say equation number 1. Correct? After this class, please do these proofs at least 2-3 times. And if you are comfortable in these proofs, queuing is very easy. That is my promise. That is my queuing will be very easy. That is my promise. You will not find queuing difficult if you stick to the proofs that I am giving in the class. So Ls is nothing but, put this thing formulas here. Rho P naught plus 2 rho square P naught okay. Like the geometric series, na? This type of geometric series we have done in 12th class. Equation 1 multiplied by rho, and start writing from here. Rho square P naught plus 2 rho Q P naught, because it will be, and it goes to infinity. Let us say equation number 2. Subtract. So Ls 1 minus rho is equals to, take P naught common out, rho plus rho square plus rho Q and this will be P naught rho over 1 minus rho. Correct? P naught is 1 minus rho. So this will cancel out. So LS will be rho over 1 minus rho. This formula you must have mugged up. That's how the proof comes out. That's how the proof comes out. Whatever the situation, stick to the basics. Whatever the situation, stick to the basics. It will be really great if it is a live session, but no problem. Doubt, you please direct it to me. Length of Q. Length of Q from C to infinity n minus Cpn. C is number of servers. C is number of servers. And how many number of servers are there in this problem? 1. Because we are discussing single server problems. There is only one server. So n is equals C is equals to 1 here presently. So LQ is nothing but summation 1 to infinity n minus 1 Pn. C is the number of servers, and initially we are discussing single server infinite length problem. Okay, just put it here. So LQ, if 1 means 0, put 2. So P2 plus 2P3 plus 3P4, and it goes to infinity. Check whether it is okay. We know that Pn is equals to rho raised to power n P naught. That we know. How this formula comes? By superimposing exponential and the Poisson distribution. We have very good mathematics faculty and probability and statistics. They are going to teach you very well all these normal distributions. Mechanical engineering, you cannot learn without understanding the probability distribution, because metrology, everything is normal distribution. And fortunately at PW, we have very good mathematics faculties at GATE. Okay, so LQ rho square P naught plus 2 rho Q P naught plus 3 rho 4 P naught. Let us say equation number 1. Multiplied by rho. Equation number 1 multiplied by rho. So LQ into rho is equals to, start writing from here, rho Q P naught 2 rho 4 P naught. Now subtract. So LQ 1 minus rho. Take P naught common from here. Rho square plus rho Q plus rho 4. We also know that P naught is 1 minus rho. So these things will cancel out. So LQ is rho square plus rho Q A divided by 1 minus R. So that is the length of Q. Subjected to rho is less than 1. So this is length of Q. Correct, na? In all these derivation, if rho is greater than equal to 1, Here very carefully, in this row is greater than or equal to 1, then the queue cannot be exhausted. This series cannot converge. So this is called exploded queue. Exploded queue. If the queue that cannot be converged, it is called exploded queue. So in the practical life, if there is an exploded queue, better to have multiple servers. In practical situation, if there is a situation of exploded queue, better to have multiple servers. So here we have derived certain things. Okay, length of system, length of queue. Now, if the question asks about waiting time in system, WS is nothing but LS divided by lambda. Lambda is an arrival rate. We are dividing by lambda. If the question is asked waiting time in queue, it will be LQ by lambda. We do not divide by mu. It is lambda only. So these are some of the things that you have to remember. Now, probability that arrival has to wait in system for time more than t is e raised to power minus t by ws. Ws is the waiting time in system. E raised to power minus t by ws. So these are the things that you have to remember. Probability that arrival has to wait in queue for more than time t. In the queue for more than time t is rho times e raised to power minus t by ws. It's same thing but multiplied by rho. So you have to be a bit careful about these formulas. There is something called average length of non-empty queues. Whenever this question comes, that average length of non-empty queue, you know what is the meaning? In the calculation of LS, you know why I'm writing? Because these notes we are going to supply to all of you. So everything should be there in the notes, okay na? I will generate PDF and it will be available on PW app, okay? So how we are calculating the LS? It is the average number in the system. Average number in the system, and how we have calculated average? The time period during which the system is idle. The time period during which the system is idle, that time also we have taken into consideration. Once again, this LS is also average number of customers in the system. LS is also average number of customers in the system. But while calculating the average, we have added the time during which system is idle. But now I want to calculate the average length of system, and I want to remove this idleness. I want to calculate the average when at least somebody is there in the system. I want to calculate the system average when at least somebody is there in the system. That is called average length of non-empty queues, and it is ls divided by ls divided by 1 minus p naught. It is ls divided by 1 minus p naught. So please remember that if the average length of non-empty queues are asked, you have to divide ls divided by 1 minus p naught. P naught is probability that there is nobody in the system, and 1 minus p naught is the probability that at least there is somebody in the system. Okay, so we have discussed some theory. Based on this theory, let us try some numerical so that we understand what we are learning. Job arrives in a machine shop following the Poisson distribution. With a mean rate of 1 per hour. So lambda is 1 per hour. If the average time to complete the job is 30 minutes, so service rate is how much? 2 per hour. One job can be completed in 30 minutes. So rate of providing service is 2 per hour because the unit should be same. Our unit should be same. What is the probability that at least 2 jobs will be waiting always? What is the probability that at least 2 jobs will be waiting always? You know what is the meaning? This is the server facility. One person is being served. Now there is a queue. What is the probability that at least 2 jobs are waiting always? So this is the at least 2 jobs means at least 3 people in the system. Probability that number of customers are greater than or equal to 3. What is the probability that number of customers are greater than or equal to 3? That's what the question is asking. Can I say it is 1 minus probability that number of customers are less than 3? Correct, na? Because summation of all the permutation and combination of probability will be equal to 1. So our 2 jobs will be waiting always means what is the probability that number of customers in the systems are equal to or greater than 3? So probability that number of customers are less than 3 is nothing but P0 plus P1 plus P2. Is that okay, na? 3 will come here. So P naught is 1 minus rho. P1 is rho P naught. And P2 is rho square P naught. And the rho is equals to 1 by 2. So this is 1 by 2. So it is a 1 by 2 square. So it's a 1 by 2 whole cube. So this probability will be the answer. Okay. And my answer coming out to be 0.125. My answer is coming out to be 0.125. Answer for this question. So queuing problem, you have to be a little careful. You read the question properly. First of all, understand what the question is asking. First of all, understand what question is asking before attempting to solve it. This is the next question. A computer terminal receives job for processing at a mean rate of 120 per hour. So lambda is 120 per hour. Processing time is exponentially distributed with a mean rate of 150 per hour. So rho is lambda by mu. So 120 by 150. So 4 by 5. So that is the information we can gather from this one. What is the mean idle time per hour for computer terminal? Mean idle time per hour for computer terminal. So first of all, calculate the percentage idleness. 1 minus rho is equals to 1 minus 4 by 5 comes out to be 1 by 5. Comes out to be 1 by 5. So per hour, if you want to calculate, multiply by 60, so 12 minutes. In 1 hour, approximately for 12 minutes, system will be idle. Approximately for 12 minutes, system will be idle. Mean number of jobs waiting for processing. It is nothing but length of queue. It is nothing but length of queue. It is nothing but rho square divided by 1 minus rho. We have proven this formula. So rho is given. You can find out. This answer is 3.2. Once again, because I am taking these questions from books, my book, industrial engineering book, and this book will be available in open market from February onwards, Narosa Publications. So all my books Narosa is publishing now. Previously there was some other publisher. Now Narosa has taken over the entire bundle of my books. Okay, na? So we are modifying, we are incorporating a lot of changes, and my friends are the co-authors in industrial engineering. IIT Indore, my friend Professor Anand Pare will be the author, and in production engineering book, my BITS Pilani colleagues, Professor Nitin and Professor Suresh will be the co-authors, because there I'm adding 3 more chapters in production engineering. So February, I think you will get these books in market. Mean waiting time per job. WQ is nothing but LQ by lambda. LQ we have calculated. Lambda we know. Comes out to be 1.6. Mean waiting time per job. Percentage utilization of terminal. Rho is the percentage utilization terminal. So 80%. Terminal is utilized for 80%. Terminal is utilized for 80%. Okay. See the next question. Queuing questions are easy, na? Queuing questions are easy. In a machine shop, you please read the question. In a machine shop, certain type of machines break down at an average rate of 6 per hour. In this, customers are machines. Customers are machines. So suppose the machine breakdown happens, there is a repairman. Repairman goes from machine, repairs it, it's on, it goes to another machine. That is the way it happens. So when the machine breakdown happens, those machines will also be in the queue. But of course, the service facility is going from machine to machine, repairing this machine, repairing that machine. Okay? So here the customers are machines. And the breakdown happens at an average of 6 per hour. So lambda is 6 per hour. Breakdown happens at an average of 6 per hour. Estimated cost of idle machine is rupees 15 per hour. Because when the machine is down, there is no production on that machine. I request all of you to understand this question very, very thoroughly. There are a lot of details in this question. First two questions was easy because to warm up, it was warm up questions. First two questions were warm up questions. So when the machine is down, it is not producing anything, and that is costing us 15 rupees per hour. That is costing us 15 rupees per hour. The repairman to repair A and B with different skills are being considered to be hired as repairman. There are two repairmen, repairman A and repairman B. A takes 6 minutes on an average to repair. So lambda is in per hour, so put the service also in per hour. 6 6 minutes means 10 per hour he can repair. And his wages are rupees 8 per hour. His wages are rupees 8 per hour. Whereas the repairman B takes 5 minutes to repair the machine. So it is 12 per hour. 5 minutes for 1. So in 1 hour he can repair 12 machines per hour. But his wages are rupees 10 per hour. His wages are rupees 10 per hour. Which repairman's service should be used and why? Assume 8-hour work shift. Assume 8-hour work shift. Work shift is 8 hours. So all the data I have written concisely. Based on that data, I have to decide that which repairman service I should take, repairman A or repairman B. Whatever is cheaper to us, that repairman we will hire. Whatever is cheaper to us, to the company, that repairman service we will hire. So let us see repairman A. If I am hiring repairman A, how much money will go from my pocket? If I am hiring repairman A, How much money will go from my pocket? So calculate the length of system. Length of system is, on an average, how many machines are down all the time. Length of system is, on an average, how many machines are down all the time. I'm not taking length of queue. You know why? When the repairman is correcting that machine is not producing anything, na? So unless and until it is reinstalled after repair, machine is not producing anything. Unless and until the repairman reinstall the entire machine, it is not producing anything. So it will not be LQ, it will be LS. LS is the average number of machines in the system. What is the system? Either under repair or waiting to be repaired. So these many number of machines are not producing anything. So rho is lambda by mu 6 by 10. So 6 by 10 divided by 1 minus 6 by 10. So 6 by 4, 1.5. So 1.5 is the length of system. So if I am hiring repairman A, approximately 1.5 machines will always be there in the breakdown state. So total cost will be 1.5 machines always under breakdown, and each machine money goes as rupees 15 per hour. That is costing the company rupees 15 per hour. And there is a 8-hour work shift. So this much money will go from the machine side. And how much money will go from worker side? 8 into 8. Because the wages I am paying is rupees 8 per hour. And there is a 8-hour work shift. So if I am hiring repairman A, the total money that will go from my pocket is rupees 244. Total money that will go from my pocket is rupees 244. Same thing, if I am hiring repairman B, how much money will go from my pocket? Of course, I'm assuming that all of you must be having ready pen and paper. So all these questions you are also solving along with me. So now rho is 6 divided by mu is 12. Because repairman B is having slightly higher service rate. LS is nothing but rho divided by 1 minus rho. 0.5 divided by 1 minus 0.5 comes out to be 1. So total cost will be 1. If I am hiring repairman B, on an average, one machine is idle all the time. How much I have to pay? 15 rupees per hour, and there is a 8-hour work shift. His wages are rupees 10 per hour, and it's a 8-hour work shift. So if you solve, comes out to be 200 rupees. Comes out to be 200 rupees. So which is cheaper? This is cheaper to us. So I will hire a repairman B. I will hire repairman B. See, whatever questions I am taking in queuing, for practice, these questions already appeared either in GATE or in UPSC. I'm not taking any manufactured question on purpose. I have some developed questions also, but when we are meeting personally, either live or something else, we will discuss. All these questions are competitive examination questions. So I will hire repairman B. Next question. Arrival to system follows a Poisson distribution. I will tell you one thing, as I told you in the beginning of the lecture, for GATE and UPSC, whenever I say, it is IFS, IES, IRMS now, and civil services, all the 4 exams. Their mechanical engineering comes. And many of my students cracked all these, including civil services with mechanical. Even the last UPSC exams also, 2 students of mine, they cracked civil services and finally they are selected with mechanical subject. So arrival to in all the competitive examinations, it will be Poisson, arrival, and exponential service. Okay. Arrival to system follows a Poisson distribution with a mean rate of 6 per hour, and the mean service time is 3 minutes. 3 minutes means 20 per hour, because the unit has to be same. Traffic intensity 6 divided by 20. Then what is the expected queue length? LQ is equals to rho squared divided by 1 minus rho. What is the expected queue length? It is 0.128. Expected queue length is 0.128. You also solve. You solve along with me. What is the expected number of units in the system? Question is asking about LS. It is rho divided by 1 minus rho. Okay. The answer is 0.428. Answer is 0.428. Answer is 0.428. What is the probability that arrival has to wait in queue for more than 10 minutes? And the probability that he has to wait for more than 10 minutes in the queue is rho e raised to power minus t by ws. T is 10 minutes. ws you calculate. Wait in the queue. In the queue. It's ls divided by lambda. So you know everything. Probability that the arrival has to wait in the queue for more than 10 minutes is 0.03. That's the probability. Although it's a queue, but still it will be WS. It will not be WQ. Only thing is that it will be multiplied by rho. Traffic intensity. It will be multiplied by rho. That's it. Rest, everything will be same. Rest, everything will be same. This is the gate problem. This is the gate problem. Consider a single server queuing model with the Poisson arrival lambda is equals to 4 per hour. It's a gate problem. An exponential service mu is equals to 4 per hour. The number in the system is restricted to a maximum of 10. We cannot extend the queue more than 10 because the system is, it's a system and it can accommodate only 10. After that I will close the door, and whenever any new customer comes, when the door is closed, it goes out, never to come back again and join the queue. So these are called systems of finite length. Systems of finite length. Okay, na? This is my second case. First case was single server infinite length problem. Second case is single server finite length problem. Single server finite length problem. So here also there will not be any change in the formulas. There will not be any change in the formulas. Pn is summation n is equals to 0 our basic formulas, na? Summation n is equals to 0 to capital N, Pn will be equal to 1. Previously it was infinite. In those formulas, replace infinite with n. N is called system size. In this particular problem, the system size is 10. And the length of system will be summation n is equals to 0 to capital N Pn. And the length of queue is nothing but summation n is equals to C to capital N minus C Pn. So only the infinite will be replaced by capital N, that's it. And here the system size is 10. System size is 10. Rho is equals to 1, na? Because lambda is equals to 4 and mu is equals to 4. Lambda is equals to 4, mu is equals to 4. So rho will be equal to 1. Correct? So here apply the first formula, P0 plus P1 plus P2 plus P10 is equals to 1. And the Pn is equals to rho raised to power n P0. Rho is equals to 1. Rho is equals to 1. So there will be total 11 terms, no? Because n equals to 10, 0, 1, 2, 3, 4, up to 10. So there are total 11 terms. So can I say P0? It is 1 plus n is equals to 1. Why we are saying? Because rho is equals to 1. So P0 is 1 by n plus 1. So or 1 by 11. P0 is 1 by 11. Okay. So if there is a question on systems of finite length, if there is a question on the system of finite length, we will go to these basic formulas. Replace infinite by n. N is the system size. And then we will go by the first principle. We will go by the first principle. So now here the question is, the probability that a person who comes and leaves without joining the queue is, person who comes and joins the queue, leaves without joining the queue. This can be interpreted in two ways, and in both the ways answer will come out to be same. Okay, na? First is he finds that there is nobody in the system, so he directly gets into the facility. Once again, I want all of you to hear very, very carefully now onwards. Because to be frank with you, till now, whatever problems we have done, it is bacha problem. Now, next two problems, this problem and next problem are basically adult problem. I mean, the people who are mature. Those who digested the queuing fundamentals, for them these problems are. So now this problem, probability that the person who comes and leaves without joining the queue. First is that there is nobody in the system. He directly gets into the facility and after availing the service gets out. Means, what is the probability that there is nobody in the system? It is 1 by 11. Second is, when the person comes and finds that doors are closed, I cannot join the queue. So he will not join the queue and without service he leaves. So probability of 11th customer is also 1 by 11. Probability of 11th customer that not joining the queue, doors are closed, so he goes away, is also 1 by 11. So anyway, answer is 1 by 11A. Understood how to deal the problems of the finite length? How to deal the problems of finite length? Now I want you to help me in solving this problem. I want you to help me in solving this problem. This is civil services problem, 30 marks. This is civil services problem, 30 marks problem. Okay? It's a service facility and there's a garage. Okay? A motor mechanic has a specialized garage for servicing Maruti car. This is civil services problem. 30 marks. If you follow the proof approach, these questions are very easy questions. If you follow proof approach the way I have taught you in the beginning of the lecture, these questions are extremely easy questions. A motor mechanic has a specialized garage for servicing Maruti cars. The repair time is exponentially distributed with a mean time of 30 minutes. Mu is 2 per hour. Everything convert into same unit. Cars arrive for repair according to Poisson distribution with a mean time of 45 minutes. Lambda is 60 by 45, comes out to be 4 by 3 per hour. Can I do that? 4 by 3 per hour. 4 by 3 per hour. Garage has a waiting space that can accommodate 2 cars excluding the one being repaired. If the waiting area is full, car waits outside on the road. So now here 1 car is being served, 2 cars can wait inside the gate. If more car comes, cars are waiting outside. If more car comes, car waits outside. Okay. What is the expected percentage of cars that has to wait outside due to inadequate waiting space? You have to find out percentage cars waiting outside. Percentage of car waiting outside. So first question is very easy. Question is asking what is the probability that number of cars are more than 3. First car, second car and third car. Fourth car onwards, it is outside. So what is the probability that number of cars are more than 3? Then it will be easy to. It will be nothing but 1 minus probability number of cars are less than equal to 3. So it is 1 minus P0 plus P1 plus P2 plus P3. Because fourth car onwards is on outside. Okay. P0 is 1 minus rho and Pn is rho raised to power n P0. So 1 minus P0 plus rho P0 plus rho square P0 plus rho cube P0. You know everything. Find out that probability. Can you do quickly? Just waiting for 15 to 20 seconds. Just waiting for 15 to 20 seconds. It should be 0.1975. 0.1975 is that probability that number of cars will be more than 3. Number of cars more than 3. So 19.75% cars waiting outside. 19.75% cars will be waiting outside. 19.75% cars will be waiting outside. Correct? Read the next portion of the problem. It was a 30 marks problem in civil services. So approximately 19% cars will be waiting outside due to inadequate waiting space. Let us read. If the waiting area in the garage is full, If the waiting area in the garage is full, instead of waiting outside the garage, if any car that comes for repair goes back not to return again, find the expected percentage of customer lost due to inadequate waiting space. Suppose the car comes and the car finds that waiting area is full and my car has to be parked outside the gate, and my car is a Mercedes or Audi car. Of course, it's a Maruti service station. I don't want my car to be parked outside. So whenever car comes and he finds that waiting area is full, it goes back not to return again. So how many percentage of customers lost? Because some of you may know that 22 years I taught basically offline in the class. And till 2016, I used to teach industrial regularly. And it's a very good problem. This particular problem is a very good problem. And I used to discuss this problem in every batch. So you know what a student used to tell? What is the answer of second problem? Or is 19.75% customers will be lost. That will be their instant answer. How many percentage of customers will be lost? 19.75%. Because 19.75% customers are waiting outside. So when the waiting area is full, they will go away. So 19.75% customers are lost. That is their conclusion. But that is a wrong answer. That is a wrong answer. Now, this particular problem is finite length problem now. This particular problem is a finite length problem now. This particular problem is a finite length problem. Now the system is maximum capacity is 3 now. One car is being served. 2 are waiting in inside the garage, inside the gate in the garage. So total capacity of system is 3. Total capacity of system is 3. So system size is 3. You know what idea I'm applying in hitting question, second part of the question. Let us say LS infinite. Suppose the queue length can be extended to infinity. There is no restriction. Cars are waiting outside. It is called infinite length, correct? Na? LS infinite is nothing but rho divided by 1 minus rho. Means the customer who comes to me, 100% I am serving them. The car that came to the system, I have to repair. So average number of customers I am serving is LS, na? The car that comes to the service facility, anyway I have to repair that car. So if the system is infinite, so the length of system is rho divided by 1 minus rho. It is the customers I am serving. Customers I am serving. But now let us say there is a finite length. Now let us say there is a finite length. So how much will be that LS? because there is a restriction in the queue length. More than 3 people, they have to go out. If there are 3 customers in the system, 4th one has to move out. So percentage customers lost are ls infinite minus ls finite divided by ls infinite into 100. Previously, these many customers I was serving. Now, these many customers I will serve if there is a finite length. So percentage customers lost will be this much. Purposefully, I am taking to this route so that you understand what is the role of ls. So ls is nothing but summation n is equals to 0 to 3 npn and summation 0 to n pn will be equal to 1. So p0 plus p1 plus p2 plus p3 is equals to 1. p0 plus rho p0 plus rho square p0 plus rho q p0 is equals to 1. Rho we know that very well. Rho is nothing but lambda by mu 4 by 3 by 2, so 2 by 3. So rho is 2 by 3. Rho is 2 by 3. So p0 1 plus rho square plus rho q is equals to 1. Find out p0. Probability that there is nobody in the system, find out p0. Better to do these things in from case to case basis. You should focus on the original formulas, and this answer comes out to be 27 by 65. (27 by 65). 27 by 65. Okay. Now ls n is equals to 0 means 0. So it will be p1 plus 2p2 plus 3p3, only 3 terms. You know pn. Pn is nothing but rho raised to power n p0. P0 we have calculated. So ls is nothing but rho plus 2 rho square plus 3 rho q into p0. Rho is given, p0 is given. You can calculate ls finite. So this is ls finite, comes out to be 1.015. You can do the calculation. 1.015. And ls infinite, rho divided by 1 minus rho, 2 by 3, 1 minus 2 by 3 comes out to be 2. So percentage customers lost 2 minus 1.015 divided by 2 into 100. Percentage customers lost are 49.2%. 49.2% customers are lost. 49.2% customers are lost. 49.2% customers are lost. So in these questions, I want to tell you some of the basic fundamentals. Application of length of system. Application of length of system. Okay? Application of length of system. Of course, this is the one-shot series. Some important fundamentals in the capsule form we are trying to communicate it to all of you. Detailed classes will be slightly different. Detailed classes will be slightly different. We will be solving at least 20-25 problems. But here, one-shot series, we cannot afford to do that. See this problem. See this problem. In this problem, there are 5 server counter. There are 5 servers. See, a train reservation facility has 5 counters, each capable of handling 20 requests per hour. Mu is 20 per hour. It is related to each server. Related to each server. A train reservation facility has 5 counters, each capable of handling 20 requests per hour. The person coming for reservation arrive at a mean rate of 90 per hour. Lambda overall is 90 per hour. Assume that each person comes with 1 request only. Assume that each person comes with 1 request only. Calculate the mean number of person at any time in this facility. Mean time a person is spent at the facility. The average length of queue at each counter. Average length of queue at each counter. You know what is the meaning of this? Meaning is there are 5 queues. There are 5 queues. There are 5 queues. So this problem is called multiple server, multiple queue problem. This problem is called multiple server, multiple queue problems. Okay? So because there are 5 servers and 5 queues, for each queue, what is lambda? 90 by 5. So 18 per hour. So my rho will be lambda by mu, 18 by 20. Now see what the question is asking. Let us see what the question is asking. The mean number of person at any time in this facility. Question is asking about the system. So what is LS? Rho divided by 1 minus rho. 0.9 divided by 1 minus 0.9 comes out to be 9. This is for each row. So 9 people in each system, and there are 5 rows now, 5 systems. So total number of customers in facility is 5 into 9, 45. At any point of time, there are 45 customers. On an average, there are 45 customers in the facility. At any point of time, there are 45 number of customers in the facility. At any point of time. Now, see the second question. The mean time a person spends at the facility. The mean time a person spent in the facility. Question is asking about the waiting time in system. So when the person comes, he will join any one of these queues. So he joins one queue, and from here it gets out. Doesn't mean that he will join each and every queue. One queue he joins and comes out. So how much time he will spend in the facility? LS by lambda. LS is 9. So 9 divided by lambda. Each lambda is 18. So 30 minutes, 0.5 hours, because 18, 0.5 hours, so 30 minutes. Each customer spends approximately 30 minutes in the facility. Doesn't mean that he will join each and every queue multiplied by 5. This will not be multiplied by 5 because he will not join all the queue, na? Now, see what is the third question. The average length of queue at each counter. Here also we don't have to multiply it by 5. Question is asking about the each counter. Average length of queue that will form at each counter. Queue length is row square by 1 minus row. Average length of queue at each counter, if you put the value, it is 8.1. Approximately 8.1 customers will be there in the queue in front of each counter. Q means excluding the person being served. Q means excluding the person being served. What would happen to the queue if the arrival rate has to reach 105 per hour? If the arrival rates are 105 per hour, overall arrival rate, then what will happen to the queue? So average lambda is 105 divided by 5 means 21. Now this lambda is greater than average service rate 20. So then lambda is more than the average service rate. So rho will be greater than 1. Rho will be greater than 1. Correct, na? So the queue will be exploded queue. Exploded queue means queue will never be exhausted and it will keep on continuing. It will keep on continuing. Queue will never be exhausted. So if the lambda is 105, it will be exploded queue. Okay. So queuing problems are very, very easy problems. Queuing problems are very, very easy problems. You have to read the question properly. You have to read the question properly. Queuing problems are very easy problems. And of course, if there is any question and all that, you please direct all your questions to me in the Telegram channel. Below this video, there is a link where you can join the Telegram channels of PW Mechanical. Okay, na? So you are welcome to ask anything over the Telegram channel. This is a very beautiful question. This question is IES question. Engineering services, this question appeared. So same lecture is, any exam of UPSC, IFS, IES, IRMS, and then civil services, GATE, everything you can drive the fundamentals from this particular lecture. So let us read the problem carefully. By the way, this problem was 25 marks in engineering services. 25 marks in engineering services. Workers come to tool room store to inquire about special tools needed in a particular project. The average time between the two arrivals is 40 seconds. There is a tool room. Tool room, and here there is a server. Tool room in charge. So when the worker comes, he will give the tools and the worker goes away. By the time more worker comes, they will form a queue. They will form a queue. This is the system, and this is queue. Correct, na? Okay. So data we will keep on writing here. Workers come to tool room to inquire about special tools needed in a particular project. The average time between the two arrivals is 40 seconds. Lambda is 60 by 40 per minute, 3 by 2 per minute. Correct? The average time of the tool room attendant is 30 seconds. Mu is 60 by 30, 2 per minute. So mu, it has to be the same unit. The average queue length. So the question has got two parts. Average queue length is nothing but rho square divided by 1 minus rho. Rho is lambda by mu. 3 by 2 by 2 means 3 by 4. So LQ is 2.25. Correct, na? Question is telling the average length, average queue length. Average length of non-empty queues. What I told you about non-empty queue? While calculating the average of the system, I am removing system idleness. While calculating the average, I am removing the system idleness. So average length of non-empty queues is ls divided by 1 minus p naught. And ls we know, rho divided by 1 minus rho. ls we know. Question is not asking about the. This the third question is ls, na? Third is ls. Rho divided by 1 minus rho. 3 by 4 divided by 1 minus 3 by 4. So 3. So 3 divided by 1 minus P naught is rho, and rho is 3 by 4. 3 by 4. So answer is 4. Okay. Mean waiting time of an arrival. See, whenever the mean is given, it means related to Q. In the question, this Q or system, these names will be mentioned very, very clearly. The Q and the system, the names will be given very, very clearly. But when it is not clear that it's a Q or system, mean refers to Q and the average refers to system. Once again, I will repeat all these things. Once again, I will repeat. In the question, you have to read the queuing problem very, very carefully. It will be directly asked in the question, queue length, waiting time in queue, or system length, system waiting time in system. So when the name system and queue are given in the problem, we don't have to worry about it. But suppose in these two questions, neither queue is written nor system is written. Now we will do this interpretation. Mean means Q, average means system. Mean means Q, average means system. Kindly do not forget this thing. In your short notes, please write this particular point. Mean means Q and average means system. So mean waiting time of an arrival is WQ, and average waiting time of an arrival is system time. So LQ by lambda, and it is LS by lambda. LS by lambda. So this comes out to be 1.5 minute, and this comes out to be 2 minutes. 1.5 minute and 2 minutes. So now we have learned a very important concept with the help of this problem. Problem is not yet over. Problem is not yet over. Problem is not yet over. But easy part is over. Easy part of the problem is over. Okay. All right. Now let us read the second portion. It was 25 marks problem in engineering services. Okay, now I am sure those who are watching this video, they are not only preparing for GATE, they will also prepare for engineering services, IRMS, civil services. I cracked civil services in 1998 with highest ever marks in mechanical. So I know the all nitty-gritty details. If you have any question, please write it to me. I will take care of everything. Okay, na? Any doubt? I will respond. Okay. Huh. Whether additional tool storeroom attendant is needed, additional tool room attendants is needed to minimize the combined cost of attendants' idle time, and the cost of workers' time. Assume the charges of skilled worker is rupees 15 per hours. Rupees 15 per hour is a skilled worker. Those who are in this queue, those workers in the queue are skilled worker. The moment worker join the company and comes out completely, he is idle. And rupees 15 rupees per hour is going from my pocket. All these people are skilled workers, and the charges are rupees 15 per hour. And that of tool room attendant is rupees 4 per hour. Rupees 4 per hour is this attendant. Okay. Also 8 hours, working hours is 8 hours a day. 8 working hours a day. So now what question is asking? What is the question? Question is, shall I have a single server, or shall I go for 2 server or multiple servers? So you have to suggest me whether I go for a single server or multiple server. Understood? That is the problem. Okay, now I have to suggest that shall I continue with the single server, or shall I hire another tool room attendant, 2 or 3 tool room attendant, to minimize my cost. Okay. So this is over now. My problem remains here. So I am taking care of that problem now. Okay. So I am moving to the next slide. My basic formulas will not change. Summation n is equals to 0 to infinity Pn is equals to 1. Ls is nothing but summation n is equals to 0 to infinity nPn. Lq is nothing but summation n is equals to c to infinity n minus c Pn. These formulas will not change. Multiple server finite problems are also possible. Here it will be n in place of infinite. Okay, na? But for multiple servers, there is a change in the formula for P naught. So Pn is rho raised to power n over factorial n P naught if n is 0 less than c. But when n is greater than or equal to c, it is rho raised to power n c raised to power n minus c factorial c P naught. So for multiple server, only these things will change. Rest everything will be same. Previously what we have done, Pn is equals to rho raised to power n P naught. single server. For multiple server, this is the situation. Now, if it is a single server, how much is the total cost? Three skilled workers are always in the system. They are not doing anything. Three skilled workers, two such problems we have already solved before. Correct now? So now you cannot say that how the three. This problem we have already solved 2 times. So if there is only single server, 3 skilled workers are already there in the system. They are not doing anything. How much I am paying? 15 rupees per hour, 8-hour work shift. So this much money we have to pay from the skilled worker side. And how much I am paying to the tool room attendant? This much. Okay, na? So it is 392 rupees. So it is 392 rupees. Presently 392 rupees are going from my pocket. Presently 392 rupees are going from my pocket. And now let us say if I am employing another server. If I am employing another server, so situation will be there will be 2 storeroom attendants and there will be single queue. So there are 2 servers now. There are 2 servers now. Summation 0 to infinity Pn is equals to 1. So apply here. So C is equals to 2 now. So this formula will be there for 0 and 1. And 2 onwards, this formula will be there, correct, na? So 0. N is equals to 0 is 1, factorial 0 is 1. So it's a P0. Apply N equals to 0. So P0, N equals to 1 plus rho P0 divided by factorial 1. Now for 2 onwards, I will use this formula. Rho square P0 divided by 2 raised to power 2 minus 2 factorial 2 plus apply 3 here. Rho Q P0 divided by 2 raised to power 3 minus 2 factorial 2 and so on will be equal to 1. So here this will be series. This will be series. Keep these 2 things separate. In the beginning of lecture, we have done the same thing, na? Modified geometric series. Same thing I will do, but this will be series, this will be separate. So as there is a time, you please keep on moving that. So P0 plus rho P0. This is a separate, na? P0 plus rho P0. P0 by factorial 2, you take common. P0 by factorial 2, you take it common out. So rho square plus rho q by 2 plus rho raised to power 4, 2 raised to power 2 up to infinity will be equal to 1. Take rho square also common out. Take rho square also common out. P0 1 plus rho plus P0 rho square by factorial 2 1 plus rho by 2 plus rho by 2 square infinite is equals to 1. Now it's a geometric series. It's a geometric series. You know everything. You know rho. You know rho. And this series, what is the summation of this series? Summation 1 divided by 1 minus rho by 2 is the summation of the series. So put everything, calculate P naught. You know the value of rho. Put everything, calculate the value of P naught. Multiple server problems are very specific problem too. The way the problem is given, it is very specific. So 30 seconds I am waiting so that you can do this calculation. 30 seconds I am waiting so that you can do this calculation. Seconds I am waiting so that you can do this calculation. If you know that, if you are good in mathematics, these problems are very easy. If you are good in mathematics, these problems are very easy. P naught is 0.455. You know, it's a one-shot series. It's a recorded mode it is going. So what I recommend, because based on my 23 years of teaching experience, those who are doing coaching, 50% students are poor in mathematics. I understand that, because those who are coming from, especially coming from diploma side, or those who are coming from private colleges, some of the private colleges students are very good in mathematics. But let us say class of 450, generally I used to class of 450 I used to teach. So 50% people have problem in mathematics. So what you do, you pause the video and do all calculation and match the answer. You pause the video. All these one-shot series you have to keep ready with pen and paper and solve. Pause the video and then solve it. But all those students, those who are weak in mathematics, I suggest them, they should not miss our mathematics teachers class. We have two very good mathematics teachers. Very good mathematics teachers. I personally discussed with them. They are very good teachers. So take the advantage and ask questions. All right. I personally say, because I have taught at different places, 23 years, our mathematics teachers are excellent. All right. So P naught is 0.455. To compare the cost, if there are two servers, I should calculate. I should be in a position to calculate LS, na? I should be in a position to calculate LS. Only then I will be able to compare the cost, na? So now LS is summation n is equals to 0 to infinity npn. That's what it is. Pn is rho raised to power n p naught. P naught we have calculated. P naught value we have calculated, and we got the numerical value also P naught. So just apply these things. LS this is for LS is nothing but P1 plus 2P2 plus 3P3 plus 4P4 and so on. For 0 and 1, this will be Pn, and 2 onwards, this will be Pn. Okay? So LS only for, because 0 is factor itself is not there. So for P1 only, I will use first term. Here onwards, it will be second term. This is the first term. This is the second term. So just keep on applying. Just keep on applying P1. It's a rho P naught divided by factorial 1 and P2 onwards I will be using this term. P2 onwards I will be using this term. 2 rho square P0 divided by 2 raised to power 0. 2 raised to power 0 factorial 2 plus 3 rho q by P0 divided by 2 raised to power 1 factorial 2 infinite. Keep this thing separate. Rho P0. From here, take rho square P0 by factorial 2 common out. So it will be 2 plus 3 rho by 2 plus 4 rho by 2 square infinity. Okay. Okay, na? So okay, you can do one thing. Let us say this is S. So S is nothing but 2 plus 3 rho by 2 plus 4 rho by 2 square multiplied by rho by 2 here. S into rho by 2. Start writing from here. 2 rho by 2 plus 3 rho by 2 square. Subtract. If you subtract, you will get S 1 minus rho by 2, 2 plus rho by 2 plus rho by 2 square. Now it's a proper geometric series. It's a proper geometric series. Put everything here. Find out LS. Put everything here. Find out LS. Can you do quickly? Find out LS. Quickly, can you solve it? My answer comes out to be this in expression form. In expression form, this is my answer. This is my answer. Okay. And my final answer will be 0.87. So if there are two servers, average length will be 0.87. So now same thing, I will calculate total cost. On an average, 0.87 people will be in the system. And how much is the cost? Skilled worker. Skilled worker cost is how much? 15 rupees per hour. 15 rupees per hour. Now there are two servers, and their wages are rupees 4 per hour. Rupees 4 hour, and it's a 8-hour work shift. This is also 8-hour work shift. This is also 8-hour work shift. So it comes out to be 168 rupees. So when there are two servers, I have to pay 168 rupees. And when there is a single server, I have to pay 392 rupees. So what is my conclusion? By employing second server, second tool room attendant, my cost is cheap. My cost is cheap. So my conclusion is second server is required. Second server is required. My conclusion is second server is required. My conclusion is second server is required. So with the help of this problem, we learned many good things. We learned many good things. So I recommend to all of you that whatever we are discussing, whatever we are discussing in the queuing theory, at least go through once. Otherwise, see this video at least 2 times. So you will get everything is clear. Let us say first time, what I recommend, first time you are with the pen and pencil. Second time, let us say you are going in bus, 2-hour journey. So just keep on hearing what I'm saying. Fundamentals will be crystal clear. Fundamental will be crystal clear. Now in the queuing, we use some notations. Let us say A, B, C, D, E, F. There are 6 things that are written. There are 6 things that are written. So you should know what is what. You should know what is what. This is probability distribution of arrivals. Probability distribution of arrivals. If it is M is Markovian. Markovian means Poisson arrival. Markovian means Poisson arrival. It is not a poison, eating poison. I have seen recently some videos of our founder, Pandey sir, that poison, giving the poison to some his assistant. There is a very beautiful shot. It is not that poison that by eating there is a death. Poison is a probability distribution. Poison is a probability distribution. Some of these shots are really excellent. Teaches very good important concept of physics. Okay, na? So shots all of you should see some of these shots. So now Markovian, M means Markovian. Markovian means Poisson arrival. Now the second is probability distribution of service, and if it is M, Markovian, it means it's exponential service. My service probability distribution is exponential probability distribution. Okay. The C is number of servers. C may be 1, 2, 3, 4, means single server, 2 server, 3 server, 4 servers. C means it tells you the number of servers that are there. This D is Q discipline. Q discipline. Q discipline means first come first serve. The person who came to our facility, he should be served first, or last come first serve. That discipline is also there. Last come first serve. Red tag. By the way, in India, red tag, there are a lot of red tag queue discipline. You know what is a red tag? Suppose some person comes with a VIP request. So he will directly go and show the card and he will bypass all the queue. It's a red tag method. Okay, na? I will tell you one example. Vistara airline. There's a customer care. Okay, na? So the moment you are calling customer care, your call will be in a queue. Your call will be in a queue. And sometime, by God, I'm telling you, it takes 35 minutes or sometime 45 minutes just to, when somebody from the other side is answering your call. Sometimes 45 minutes, I have waited. But now, suppose somebody from the business class calls them, or they have at least the silver card members, because for some time they have upgraded to my silver card. So when you are calling, your phone number is a silver card member, immediately it's a red tag. I mean, your call will be answered within 2 minutes. You try otherwise. Some of you, those who are aiming, you try. It takes 45 minutes normally, but if you are a silver card member or a business class I never traveled, but silver card, because frequent flyer, silver card I have. So the moment I call with that number, within 2 minutes the person is answering. So queue discipline, that queue discipline is a red tag. Some VIPs are there, call them first for the service, bypass the queue. So D is the queue discipline. Please remember, D is the queue discipline. Now, this is the queue length. Queue length means whether it can be extended to infinite, or let us say 1000 or 10. What is the queue length? Like we have discussed some finite length problems. So it tells you about the queue length. Now, F is called calling source population. Calling source population. I will give you some example. Train reservation facility. Anybody from the public, they can come and join. So that will be infinite. Calling source population is infinite, means anybody from the anybody from India, whoever is the caste, creed, everybody can join. Beggar and rich person, everybody can join the queue. So calling source population is infinite. But suppose the service facility is, serving Mercedes-Benz cars. See, I am recording this lecture in Hyderabad. In Hyderabad, let us say there may be 2000 Mercedes-Benz cars. So calling source population is only 2000. Only from those 2000 people can join my queue. No other person can join the queue. Understand or no? So calling source population. So these things are basically called notations. So please be careful. And that's what it's for. Discussion on one-shot series of queuing. Next lecture is also going to be very, very important. So stay tuned. Thank you very much.